Okay, so welcome to this video where we'll discuss how to solve cryptography test 2 questions by Mr. Chishala. Okay, so the instructions were: do not turn this paper until you are told to do so. This question paper contains 2 questions, attempt or questions. Write your name, student ID, and program clearly on the answer sheet. Time allowed is 1 hour 30 minutes only. Only calculators are allowed in the exam room. Okay, so we can now check out the questions you are supposed to answer. So question 1A. Using the RSA encryption algorithm, pick P as 11. So our P should be 11. Then Q 7. Then they are saying find the encryption or decryption keys E and D. Okay, so using RSA encryption algorithm, when you are given P and Q, you can use that to find N, because our N is equals to P times Q. Okay, so since we know the value for P, which is 11, and we know the value for Q, which is 7, it will be 11 times 7, which is 77. So from that we can tell that the value for N is 77. Okay, so now we can go ahead and find M for us to come up with those keys. So M is equal to P minus 1 times Q minus 1. So that's the formula for M. Okay, now again we know the value for P, which is 11, then you say minus 1 times, we know the value for Q, which is 7, again minus 1, and then you close the bracket. Okay, now 11 minus 1 we get 10, then times 7 minus 1 is 6. So now the last part is 10 times 6, which is 60. So our M now is 60. Okay, so after doing this, we can now list prime numbers which are less than n. So here we'll be listing prime numbers which are less than n. So I'll say prime numbers less than n. Okay, so remember our n is this value, which is 77. So we are listing prime numbers which are less than 77. So a prime number, as you know, is just a number which is divisible by itself and 1. Or you can say, in other words, when you try to divide it by 2, it must not give you a remainder of 0. For example, if you say 3 divided by 2, you get 1.5. So it means that 3 is a prime number. So we'll be listing like that. So we have prime numbers, which is, okay, so we'll start with 2, then 3, we say 5, 7, 11, 13. So I'll pause the video so that I list all the prime numbers which are less than 77. Okay, so that's a list of all prime numbers which are less than 77. Okay, so basically these solutions which you are seeing here will be shared on the Google Drive. So here you are just supposed to get the concept and how to do these things. Okay, so now we need to know the value for E. So for us to know the value for E, what we need to understand is how do we find E. So okay, so the value for E is just a number, a prime number from this list, and that number should not give you a remainder of 0, or should give you a remainder of 0 if you divide it with n. But again, or should not give you a remainder of 0 if you divide it by this m. So basically, if you divide it by n, you can realize that the remainder is 0, but when you divide it by m, the remainder is not 0. So that's the value for E. So let me open up my calculator, then I show you what I mean. Okay, so from this list, as you can see, our m is 60. So if I have 60 as my m, I will start dividing it by 2 first. So if I say 60 by 2, from that list, I'm getting 30, meaning the remainder is 0. So that's not our E. We go to 3. So 60, when we divide it with this 3. If the remainder is still 0, that's not our E. So as you can see, again, the remainder is 0 because it's not point something. So again, if we say 60, we go to the next number from that list, which is 5. Then we divide it from that 60. Again, we get 12, meaning that's not our E. So we are at 7 now. So 60 divide by 7. 60 divide by 7. We get 8.5, meaning our E is 7, because when we divide it with m, the remainder is not 0. But dividing this 7 into 77, we get 11, meaning once we divide it with n, it will give us a remainder of 0, but dividing it with m, we won't get a remainder of 0. So that's how we come up with E. But in a case whereby you are given the values for E, you will find that it cannot be giving a remainder of 0 when you divide it with n. Therefore, the actual conclusion for this case is to say E is a number, a prime number less than n, when divided into m, should not give you a remainder of 0. That's how we find E. For example, we said this 7, which is a list of prime numbers less than n, dividing it into m, which is 60, we are getting 8.5, which is not giving us a remainder of 0. No wonder our E was 7, the number we used from that list. So that's how we do that. So now we go to D, how to find D. So basically D has a formula which says ED minus 1, then divide by m. That's how we can find D, but it has also a condition. This formula should give us a remainder of 0. So don't get confused. The first scenario for finding E is that it must not give us a remainder of 0 when divided into m. But for D, once you compute everything, we must get a remainder of 0. Meaning the final answer of this formula should be a whole number. For example, if the answer is 4, it means it's 4, just a whole number, not 4.1 or 4.2. Okay, so now we need to compute. Our E, as we can see, is 7. Then our D, we don't know because we want to find D. So you say minus 1 from that formula over m, which is 60. So now we need to start computing, like which number can we enter in place of D, so that once we compute this formula, we get a whole number which is giving us a remainder of 0. So again, you test all these prime numbers into this missing box, which is representing D. So we will start with the first prime number, which is 2. So here is an example. We have 2, we have 7, which is this, then times 2, which is the prime number representing D in this case, which is 2, we get 14. Then you say minus, which is this 1, like that, you get 13. Then divide by 60, you get 0.2. So this is not a whole number, it means 2 is not the prime number we are looking for to represent D. So we need to repeat this process for all these prime numbers till we get the right one. So I won't waste much of the time. Let me pause the video, then find the actual number so that I show you guys. Okay, so after multiple attempts, I've realized that 43 is the value for D, because when we compute this 7, then times 43 from this list of prime numbers to represent D, like that, times 43, we get 301. Then once we say minus 1 from that formula, we get 300. So we said 7 times 43, which is 301. Then we add minus 1 divided by 60. Then 301 minus 1 is 300. We are remaining with it divided by 60. So now here we just divide it by 60 to see if this answer is a whole number. So as you can see, the answer is 5. So 5 is a whole number. Therefore, since we used 43 in place of D, it means our D is equals to 43, because we used 43 for that. So that's how you find E and and D. So just a quick revision. For us to come up with the encryption keys, the first thing we did is to make sure that we know the value for N, and N, it had the formula which is P times Q. So we just replaced the value for P and Q to get 77. Then we said we need to know the value for M, and M was the formula which is P minus 1 times Q minus 1. Once computing the values for P and Q, we got 60. Then we said let us list prime numbers which are less than N, in that case which was 77. So we listed these things as prime numbers which are less than 77. Now we said we need to find the value for E, or we need to find E in this case. So finding E, we said is just a number from this list when divided by M must not give you a remainder of 0. So in a case where we said 60 divided by 7, we are not getting a whole number, meaning the remainder was not 0 because we had point something. Now we said after finding E, it can help us to find D, because D has a formula which is ED minus 1 over M. So knowing the value for E, which is 7, we said we need to find the value for D. So this was just blank, then minus 1 divided by 60, which was representing M. Now we were testing each prime number into this formula so that the answer should give us a remainder of 0 or a whole number. And 43 is the number which happened to give us the whole number, which is 5. Meaning since we used 43 will represent D, because it was replaced where they were supposed to be D. Okay, so now we can come up with the public and private keys. So we have let me follow the question. We have RSA public encryption key, like that. Okay, so public encryption key for RSA is denoted by N, E, like that. Then we know the value for N, which is 77, and we know the value for E, which is just 7 from this. Okay, so 77,7 will be the RSA public encryption key used to encrypt a certain message with this given information. So we need to understand that these this public encryption key have a formula. So the formula, since we're encrypting something, we want to get the each ciphertext, which is C. So the outcome, which is ciphertext, can be obtained when you say we are encrypting something which is in plain text, and plain text in this case is represented by M. So we are encrypting that, so we say power E for encrypting, M power E, then mod N. That's the formula. So let me explain the formula again. We have C, which is the ciphertext we want to obtain because we're encrypting something. M is the plain text being encrypted by this encryption algorithm denoted by E. Because RSA uses modulus to obtain a big value into a smaller value, and we're saying mod N, which was the 77. So since we know the value for M is just a plain text, so I will just say M because I don't know any plain text to encrypt in right now. So power E, which is 7, we say 7, then mod N, which is 77. So that's the information for the RSA public encryption key. Okay, so now let us come up with the RSA private decryption key. Private decryption key. Okay, like that. So it's denoted by N comma D because now we are decrypting. Okay, so let me explain something first. We call it a public key when we are encrypting because it's in the public domain. Let me give an example. An email address is a public domain, so it's used for encrypting. Anyone can access your email address publicly. Let me say you just go on social media, then you share your email, anyone can contact you. So that process of contacting you is that they are obtaining the public encryption key, which is your email address. They send you that message, then that message will be encrypted, and you are the only one who can see that message once decoded because you have the password. No one knows your password. So RSA is an example of asymmetric encryption or cryptography. So that's the meaning. So for RSA private encryption key, we need to understand that our N again was 77, then our D 43 based on what we have found. Okay, now the formula for RSA private decryption key, because it's called private because you are just the one owning it, more like a password. So we want to obtain, since we have something which is in ciphertext, it has been encrypted, we want to obtain it now to its original format, which was the plain text. So M for the plain text can be obtained when we say that ciphertext, the ciphertext, then its decryption algorithm, then mod N. So that's the only way you can master these formulas so quickly, by understanding that theory. So ciphertext, we don't know the ciphertext we are decrypting. So decrypting it was 43, as you can see. Then we say mod 77, which is N. So that's how you solve this first question, which is A.